Hello everyone, it's me Damian, tutor from 30. So in this video, I'm going to go through the Form 4 Mathematics, Chapter 5, okay, by looking at the textbook questions. So without further ado, let's go into the notes. So I'm going to go through the comprehensive practice here. So in Chapter 5, okay, Network in Graph Theory, in this chapter is all about looking at your networks, which is formed by the graph. Okay, all these connections between different points will be your graph. Okay, so there are two types of graph. One is called the simple graph, and one is called the graph with multiple edges and loops. Okay, so if you just look at some of this here, this one right here is considered a loop, and these ones are your multiple edges. Multiple edges, those that connect between the vertices, but not with just one connection, but with multiple connections to it. That is your multiple edges, and loop will be just from one point going back to itself. Okay, so each of these lines are considered an edge. A loop is considered an edge. Your multiple edge, each of it is considered one edge. All these points are called your vertices. Okay, each of these points are the vertices. And we also have what we call degree. What are degrees? Degrees are basically how many edges are there connecting to that particular vertex. Okay, how many connections are there onto that point? Okay, it's just like imagine if you're in a building. Okay, so there is one exit connects to this road, one exit connects to this road, one exit connects to this road. So in this case, there are 3 degrees, because basically there are 3 pathways, okay, for it to enter and exit in a sense. Okay, so it can be without any direction. It can also be with direction. So if you see this, when there's an arrow pointing, that is with directions. When there's no arrows, then it's without direction. Okay, so the edges can have directions. It can have no directions as well. It depends on the network, the graph that is given to you, or that you are supposed to draw. Right? So if we look at the first question here, they're asking for set V, set E, and sum of degrees. So set V means a set of your all the vertices. Set E means a set of all the edges, and sum of degrees means sum of all the degrees. Okay, means sum of all the degrees for all of the vertices. Okay, all of the vertices. So let's look at set V. So we do one by one for A, B, and C. If we just look at the A first, set V. So I write it in a set notation form. V equals, and we use this set bracket. And we just list out all the vertices that are there inside, which is your P, Q, R, S, T, U. Yeah, these 6 vertices. P, Q, R, S, T, and U. That's for the first one, set V. Second one, set E. Set E is basically all the edges. So as we list out the edges, it's good for you to make a marking on the edges that you have listed out. Okay, then it ensures that you don't miss out any of the edges. Okay, as you list them out. So we list them out by linking. where it connects to. So the first one would be the P and Q. Then I have this one, P to S. And this one, P to U. Okay. So if I've already listed P to Q, P to S, P to U, I don't go and list out Q to P again. I've already listed out this edge, so do not go and list out the same edge again. Okay. Then let's move on to from the vertex Q. So we have Q to R here and Q to T here. So we list out QR and QT. Then from R, we have RS and RU. RS, RU. And from S, we have ST. And from the T, we have this TU. So that's it. These are all the edges in the A1 here. Okay. Then, so A2, I mean. And the third one is sum of degrees. Now, sum of degrees actually very simple. We can always use this formula. Sum of degrees. We can use this symbol also, the sum symbol, and then the D. V for all the vertices is 2 times of the number of edges. It will always be 2 times of the number of edges. It doesn't matter whether it has loops or multiple edges or not, or it's just simple graph. No matter what, it will be 2 times the number of edges. Okay. So the one here, sum of degrees, I can just take 2 times of the number of edges. So each of this bracket is 1 edge. So in total, there are 9. So 2 times 9, I'll get 18. Yeah, so in total, there are, the sum of degrees will be 18. That's part A. Then part B. Same thing. First one, set V. Just list down all the vertices. So we have P, Q, R, S, T, and U as well. Okay. Then set E, set of your edges. So we have P going back to itself. Okay, P going back to itself. So from P and go back to P, so we list it as PP. Then we have P to Q and P to R. Yeah, PQ, PR. Right? Then if I go from Q, there's an edge connects to R as well. So QR. From R, there's an edge that connects to S, RS. From S, you can see there are 2 edges here that connects to T. So ST, I need to write it twice because if I write once, it only represents 1 edge, but there are 2 edges that connects between S and T. I need to write once for each of them. So I write it twice. Okay, ST, ST. And there's nothing to use, so don't need to write anything. Then for B3, sum of degrees, again, we just take 2 times of the number of edges. So number of edges 1, 2, 3, 4, 5, 6, 7. 2 times 7, and I will get 14. Yeah. Sum of degrees is 14 for the part B. And then for part C. For part C, set V, list down all the vertices. I have P, Q, R, S, and T here. So P, Q, R, S, T. Second one, set E, set of all the edges. So this one, you can see there's an arrow, there's direction. So we need to list out your edges according to the direction as well. Like here, it goes from P to Q. So I have to write PQ. I cannot write QP. Okay, it has to follow the arrow. So first one, PQ. And there's also one from P to S. So PS. Then if I start from Q here, it doesn't go anywhere. Start from R. R goes to Q. So there is RQ. Okay. Then from S, there is SR, SP, and ST. All three of them from your point S. So SP, SR, ST. SP, SR, and ST. Yeah, so these are all the edges in the part C here. Oh, sorry, I missed out one. My bad. There is also the loop TT. Okay, from T back to itself. TT. That is also one of the edges. Okay, this one. So you see, as I highlight, if I highlight as I go, whenever I look back at the diagram, I will be able to see, oh, there's one part missing that I did not, that I did not make a marking for. So I won't miss out anything. So C3, sum of degrees for all the vertices. So once again, I can take 2 times of the number of edges, which is 1, 2, 3, 4, 5, 6, 7. 2 times 7, 14. Sum of degrees here will also be 14. So yeah, that's how we get your set of vertices, set of your edges, and your sum of degrees. Okay. Then, if we move on to question 2, drawing an undirected graph, okay, based on the informations that are given. So drawing your undirected graph when we have the set of your vertices and set of edges given is really quite simple. But whenever you draw, any drawings that you do, always try to use a pencil to do it. Okay, because any mistakes you make, or if you think it's too messy, or you think some parts of it could be drawn better, then you could always edit it. Okay, but if you draw using a pen and you use correction tape over and over, it will really look very, very messy. Even not over and over, once you put correction tape over, it already starts not to look very nice. Yeah. So always, I would really advise drawings, use pencil to do it. Okay. You are allowed to use pencils for any drawing. So, yeah, if I look at this, part A. So I need to draw these 6 vertices, but only these 4 edges. Okay. So should I draw the vertices first or the edges first? My take on it would be, I will draw according to the edges first. Yeah. Okay, so it's less likely for me to cut across one another. So I draw from P to Q. P here, Q here. Then from Q to R. Yeah, you can just branch out R. Then there's one from R to S. So you can draw back here, you can draw here, doesn't really matter. Say I draw here. Then S to T. Yeah, you can just branch out. T. Yeah. But be aware, there's also a U here. So the U, you have to put it anywhere. Okay, you can put it anywhere, but it cannot be connected to any of this edge. So you can put it right in the middle here, you can put it outside. It really doesn't matter. So let's say I just put the U here. Yeah, that would be an example of how you can draw the graph. So basically it would be like one pathway. Okay. But how, which direction you draw it, you can put the P on the right here, go everything to the left. It's okay. Yeah, it doesn't really matter. Right? So when you're required to draw, there are really multiple ways of drawing. All right. Then for the part B, you see there's a PQ, PQ. So it's a multiple edge. So let's say I start from here to a Q. So multiple edge, I don't use a straight line. It's a curve. P, then to the Q. Right? Then from Q, it goes to R and also to T. So let's branch out. Generally, I will branch out another direction so that it's harder to intersect. Okay, harder to cut through one another. So maybe I can put R here and T here. So I've already gone through PQ, PQ, QR, QT. Then from R goes to S. R, I branch out to S. From S, I have a loop. So just loop onto itself. Then there's one more from S to T. So connect from S to T, like this. Yeah. So is that the only possible way I can draw it? So not really. P, if I don't want to put there, maybe I put P inside here like that. Yeah, like this. It will also be fine. Okay, it just doesn't look that nice because there's P inside here like this. It probably looks better like this. Okay, but like I say, there can be multiple different ways, different orientations you can draw it. It really doesn't matter. Okay, but try to keep everything neat and tidy. Don't end up crossing your path through another line if it's whenever it's possible. Means I don't want, let's say I have like this. I don't want to end up putting, let's say, IS. Sorry. The S, I don't want to end up be putting it maybe like here, like that. Then this line will like cut through another edge. Then it looks very, very messy like this. Okay, but if is in a way that it still looks neat and tidy, it's okay. Like if I put my S here, connecting like this, yeah, it's actually okay. Okay, but I would say putting your S here would still probably be the best looking one. All right. Now, let's look at another type of question. Look at question 3. Draw an undirected weighted graph to represent the federal roads connecting to a few towns as shown in the table. So you are advised to use an area map to determine the position of the towns. Okay. So yeah, let's not look at the part B first. So I want to draw an undirected weighted graph. What is weighted graph? Means on each of the edge, I assign a weightage to it. I assign a weight to it. So that weight, it can represent different quantities. It can represent like your distance, can represent maybe the price. So for example, if I take an LRT map, okay, LRT link map, I can assign the price from one station to another. Yeah, if I want to. So then the weightage that will be assigned will be the price. Okay. Or if just a location map from one town to another, one town to another, I can always assign distance to it. Okay. Or maybe a bus route map. Also, I can assign the price. Okay. Or even a highway map, then I can assign like the toll price going from here to here, here to here. Like that. So all these are possible weightage that you can have. Okay. It can even be, say, between a person and another person, that was their relation. Okay, so the relation will be a type of weightage as well, in a sense. Okay, but more accurately is what your edge is lah. Okay, but so usually weightage will be quantity lah, not really the name of the edge, but more to quantity that is countable. Okay, which very commonly it will be distance or maybe time or price. Yeah, things like that. Okay, so here I just want to draw the undirected weighted graph that shows all this distance and shows all these connections, right? So basically I need to sketch out the graph. So let's start from the below. Okay, so from the below, sorry, I branch out to Mentakap and Bandar Bera. Okay, so I branch out 2 ways. Try to keep it away so that it doesn't cut through one another. So Mentakap, Bandar Bera. Okay, from Bandar Bera goes to Teriang. So I just branch out. Teriang. From Mentakap it goes Lanchang. From here it goes to Lanchang. From Mentakap it also goes to Kuala Krau. and from Lanchang it goes to Karak. Here branch out Karak. Here branch out is Kuala Rao. Okay. Then I label all the edges with the distance, the weightage. 9.3 km, 30.2 km, Bandar Merah Tuturiang 4.9 km, Pentakap to Lanchang 21.1 km, Lanchang to Karak 21.9 km, and Mentakap to Kuala Krau 34.6 km. That's it. Just label clearly all of this, then we have the graph. All right. For part B, they want you to determine whether it is a tree and then justify the answer. Okay. Now, how is it a tree? So a tree means it cannot have any loops. It doesn't only mean the loop on the same vertex. It means a loop like this. Yeah. When it goes through different vertices, it can come back to itself. Then that's a kind of loop. Okay. So a tree has to be a simple graph. Definitely has to be a simple graph. There cannot be any multiple edge. There cannot be any loops. Okay. It also cannot have any loops created using multiple vertices. Yeah, means if it goes to different vertices, but it can come back to itself, then it's not considered a tree. It can only branch away. It cannot branch away and round back to itself. Okay. Yeah. Then each pair of vertices will only be connected with one edge. Okay. It doesn't mean one vertex has only one edge connecting to it. It means each pair has only one connection. Yeah, each pair has only one connection. There's no way I can connect this vertex and another vertex using two different ways. Yeah. If it does, then that's where the loop happens also. So like I can go from S to R straight like that. I can also go from S to R through T, through Q, like this. Here, here, here. Yeah. So it means I can have STQR, I can have SR. It will also go from S to R. Yeah. So that's where it has multiple connections also. Okay. Then there's also one more relation, which is number of edges is equals to number of vertices minus 1. Yeah. Number of edges is always number of vertices minus 1. That would also show that is also one of the property of a tree. Okay. So in this case, for part B, it's yes. Okay. Because every pair of vertices is connected by one edge. And then number of vertices. Here there are 1, 2, 3, 4, 5, 6, 7. Number of edges. 1, 2, 3, 4, 5, 6. Yeah, which shows number of edges is your number of vertices minus 1. Yeah. Okay, goes to your number of vertices minus 1. This shows this shows that it's a tree as well. All right. So yeah, if I have, let's say, one edge like this, then it's no longer a tree. If I have one edge like this, then it's no longer a tree. Okay, because then it forms a big loop. Yeah. So yeah, let's look at the next one. Directed graph here shows the roads connecting Lani's house at A to the school at E. Right? HBE is a municipal road, and edges A, B, AC, CD, and DE are roads in the housing estate. So suggest the best route that Lani can choose to cycle to school. Okay, to cycle to school. So first thing, if you read the question, you realize they specifically say BE is a municipal road. Okay, it's a municipal road. So why do they specifically mention the municipal roads? So municipal road is like the bigger kind of main roads, in a sense. Yeah, it's the bigger kind of main roads. It's like municipal road is yeah, I wouldn't really consider it a highway, but it's really those bigger kind of road. Okay, it's not exactly a highway, but it's the bigger kind of main road where there are multiple lanes, which will be very dangerous for cycling. Yeah. So I think it's quite obvious considering how they specifically say municipal road like this. That's why the best route would be not taking the municipal road, means not going from B to E, which the only possible way is going this way. Yeah, which is actually a detour. Okay, so I can say best route is from A to C to D to E. Okay. Because it is safer by avoiding the municipal road although if you compare the distance 1.1 km plus 400 meters means 0.4 km, so it's 1.5 km. Yeah, if I take ABE. The other way, 350 plus 800 plus 650 is 1,800 meters. So there's difference of 300 meters. Yeah. So although it is 300 meters further, yeah, which is still a reasonable distance to cycle lah. 300 meters, if you cycle, really doesn't take long. Yeah. 300 meters, yeah, probably in 1 minute you will be able to reach, depending on how fast you cycle. So that cycle slowly, maybe 1 minute plus, or maybe 2 minutes. But yeah, just an extra 2 minutes, but you go a safer route, definitely is a better way to choose that. Okay, so sometimes the questions may not be just all about calculations. Sometimes it involves a bit of logical thinking as well. Okay, but I think in this question, it is very obvious once if you read the question properly. That's why it's always important to read your questions properly. Read it once, read it twice if you need. Read it 3 times, 4 times, 5 times also is okay. But don't go and read it like 10 over times lah. That's a bit too crazy. So you read it once, you roughly understand. Maybe you can slowly read it another time. You can always try to see which part of it stands out. Yeah, like Lani's house at A. So that's where it starts. School is at E. That's where it ends. Then BE is a municipal road. And others are roads in the housing estate. So these are the key points that is stated in the question. So there's a reason why they state this information, because municipal road is dangerous to cycle in. Yeah. Right. Now, let's look at the next one. Question 5. So question 5 here. The directed weighted graph here shows the prices and tickets and travel times for some choices of flights of a private airline. So this is directed and also weighted. Okay. So vertex S is the destination of the flight from vertex P, vertex Q, and R are transit airports. So transit time at each airport is 45 minutes. So part A1, they just want you to state the most economical route. So economical one means the cheapest one. Okay, so I want to go from P to S basically. Okay, P to S, you can either go PRS, which will cost you 195 ringgit. You can go straight to S, 200 ringgit. This way, PQS, 165 ringgit. Or you can also go P to Q to R, then to S. 50 plus 45 plus 65, which is 160. So the cheapest one would be that longest route. A1 would be the route from from P to Q. P to Q to R, then to S, which costs 160 ringgit. Compared to the rest, 165, 195. So how you can compare them? Basically, you can always list down all the possible ways first. There is PS, there is PRS, there is PQS, and there is PQRS. Yeah. Okay, this is 200 ringgit. So by comparing it like that, you'll be able to see. Okay, if you want to, you can do up a table, you can do up another list. It's okay to do that. Okay, then you can clearly compare between them. Yeah, if you try to do everything by just looking at the diagram, it's quite easy to get confused. It's quite easy to make mistakes. Please don't worry about writing extra things. Yeah, it's always good to create your own representation of the data that is given. So A2 would be the route that takes the shortest time. Okay, shortest time. So they say transit takes 45 minutes. Okay, if I count in decimals, then it's 0.75 of an hour. Okay, so if I go from P to S, it's straight up 3 hours. PRS. So P to R plus R to S is 2.6, but I have to plus another 0.75. Okay, we have to plus another 0.75. So that 2.6, yeah, plus 0.75. So it adds up to 3.35 hours. Yeah. Okay, that's how long it takes. PQS, from P to Q to S. So it's 1 hour plus 1 hour, 1.4 hours. So 1 plus 1.4, then plus another 0.75 of an hour for the 45 minutes. Yeah, because stops at that one airport. So it will be 3.15 hours. Yeah. And actually, I don't even need to count this last one. Very obviously, it's taking the longest because each time it stops 45 minutes. Yeah, and also you need to fly so many times, definitely it's going to take longer lah. So it's 1 plus 0.75 plus 0.8 plus 0.75 for the second transit plus 1.1. So you see, it takes a whole 4.4 hours. Sorry, this is the 3.15. Yeah, takes a whole 4.4 hours. So obviously, the fastest route would be from P to S straight. Yeah, which is very expected, even if you don't count anything. Then part B, if you need to go to the destination at optimum cost, state the route that you will choose. So if you look at the time taken, compared to the price. You see, from P to Q to S, 165 ringgit, and it's 3.15 hours compared to even PRS is more expensive but takes longer. Yeah. While the P to S straight, it is the fastest, 3 hours, but it costs another 35 ringgit. Yeah. So if you really want an economical choice with just extra 0.15 of an hour, which is really not long. Okay, if I count 0.15 of an hour, 0.15 times 60, you get 9. Yeah. Okay, means it's 3 hours, 9 minutes. So it's an extra 9 minutes compared to the 200 ringgit. So definitely the best choice would be the route PQS. Yeah. So you comment on both things, the time and also the price. Okay. So if I comment on the price, because it is 35 ringgit cheaper than route P to S with only, then I look at time, 9 minutes extra. Travel time. Okay. And if I compare PQRS and only 5 ringgit more compared to route PQRS. Yeah. With over an hour difference in time. Yeah. So whether you compare the cheapest option or the most expensive option, both ways shows that the PQS is definitely the most reasonable choice. It's only a bit more expensive than the cheapest choice, but it saves so much time. It's only only 9 minutes more than the most expensive choice. So of course, I take the PQS. Okay. Then we have question 6. Write 5 linear equations based on the directed graph here. So I want to write out 5 linear equations. Yeah. So they give you x5 equals to 15. So they want you to determine x1, x2, x3, and x4. Okay. Now, let's see here. this one here. Okay, so basically the principle that is used here is how much going in to a vertex, that would be how much that is coming out of that vertex. Okay, yeah, that's what it means. That's what they are indicating from these tips. What the number is going in, the total number that's going in will be the same as total number that is going out. Everything creates a balance of your in and out of that vertex. So there's an 11 in here to the A, and it goes out x1, x2. Means x1 plus x2 is equals to the 11. Yeah, that's one equation I can form. So they want 5 linear equations. Why 5? Because there are 5 vertices here. So we can write one linear equation for each of the vertex. Okay, if I look at B, x4 in, x3 and 11 out, means x4 equals to x3 plus 11. Yeah. If I look at C, x2 and x3, 10 and 10. So x2 plus x3 equals 10 plus 10, means equals 20 lah. Okay. Then for the D here, x1 and 10 come out x5. x1 plus 10 equals x5. And for the E here, x5 and 10 come out x4. x5 plus 10 equals to x4. Yeah. Right. So from here, we need to solve your linear equations. So you're given x5 equals to 15. x5 equals to 15 means this one, x1 plus 10 equals 15, means x1 plus 10 is 15. x1 is 15 minus 10, which is 5. So I get x1 is 5. Okay, then, sorry. These are the 5 equations. Yeah. Then from here I get x1 equals 5. Then this one I can put x5 to get x4 also. So 15 plus 10 equals x4. x4 will be 25. Okay, there I have the x4. Then I can use this, the first one, x1 plus x2 equals 11 to get x2. 5 plus x2 equals 11. x2 will be 11 minus 5, which is 6. I have x2. Then x3. x3, I can use this one. x2 plus x3 is 20. Means 6 plus x3 is 20. x3 is 20 minus 6, 14. Yeah, there we get the x3 is 14. So yeah, this is how we get the x1, x2, x3, and x4. That's for the question 6 here. Then question 7. I have undirected graph here showing 6 houses in a village. A salesperson needs to visit all the houses starting from house A and finishing at house F. So draw a directed graph to represent shortest distance from A to F with the condition that all the paths are taken once only. So it needs to start at A. It needs to end at F. Okay. It needs to pass through all the 6 houses also lah. Okay. That's the hidden condition that is, yeah, hidden condition here. So how we can determine? So actually, what I would always do is, I will always try to draw a tree first. Okay, so how we draw a tree? We look at all the pathways with the shortest distance connecting to the vertex. Like E, shortest one would be this one. The B, shortest would be here. For the C, shortest would be here. E, shortest this one. For the F, shortest is this. Yeah. But this one is not one path, one straight path that goes along in one single direction. Because here it branches out 2 ways. So I cannot branch out like this, but instead I can just shift this. Instead of taking this route, I take A to D with just 100 meters extra. Yeah, so this should form the shortest path. Yeah. Any other edits? If I shift out the D instead of going to C, go to F, it's 300 meters extra. Definitely way more. Yeah. Okay, so from the tree that I can get, I just add on the least amount that I can to make it one flowing path. Yeah. So that's how it works. From A to D. Yeah, they say directed graph. So we draw the arrows as well. Then to C. Then to B. To E. And to F. Yeah, like that. Okay. Then, based on the graph, calculate shortest distance in km. So basically, we just add up all the distance here. Means I take 750 plus 500 plus 600 plus 780 plus 450. Add them all together. 750 plus 500 plus 600 plus 780 plus 450, 3080. This is in meters. So change to km, divide by 1000, 3.08 km. That's it. Okay, so this kind of question, as long as you can determine the shortest path, calculating it is very, very simple. Then we look at the question 8 here. The graph here shows the connection between the elements in set X, set Y, and set Z, where the universal set is X union Y union Z. Represent the graph in a Venn diagram. Okay, so I need to draw this out in a Venn diagram form. Means I need to show what's in set X, set Y, set Z, and what's the intersection. So those that connects to both X and Y, X and Z, or connected to all three, yeah, those will be in the intersection parts. So what I can always do, usually when I draw graph, I like to start at the innermost intersection, which is this one, the E. So I start with the E right in the middle. Yeah, the one that intersects all of them, X, Y, and also Z. Then I look at the other intersections. Between X and Z, the B intersects. So B is in this intersection here. Between Z and Y, these two, H and N. So this intersection, I put the H and the N. This intersection between X and Y will be L and the J. Then the rest of it will just be in their respective sets. So X, I have D, P, and G. D, G, P. Set Y, I have A, M, F, and T. Set Z, C, R, I, K. C, R, I, and K. That's it. Okay, this will be how I draw the Venn diagram. So always when you draw Venn diagram, start from the direct middle. Okay. Then slowly branch out the other intersections, then only the rest. Usually I always draw at that. And usually that is the most effective way. So the part B is basically set questions. Okay, it's no longer chapter 5 type of question. It's actually asking you a chapter 4 question, which if you have already familiarized yourself with the chapter 4, you should be able to do. If you have not, and you think I explained this question properly, you can always check out my video on chapter 4. Yeah. So yeah, I do have a video on chapter 4. So you can check that out if you are still unfamiliar with the chapter 4 and you haven't watched that video yet. So X union Y complement means I combine set X and set Y. Combination of these two sets together. Union means unite them together. So add them together. Complement means outside. So means everything except what's inside here. So everything outside of it, which is these 4 letters. Okay, C, R, I, and K. Okay. So yeah, put in a set bracket. C, R, I, K. So the order of the letters doesn't matter. You can put C-R-I-K, C-K-R-I, C-I-K-R. Doesn't really matter. B2, X intersect Z complement, intersect Y complement. So always look at bracket first. X intersect Z is here, complement everything else. All this. Okay. So all this, out of all this, they want intersect Y complement. Intersect Y complement means outside. So means outside of Y. So out of this part, which ones are outside of Y? So it will be this and this part. Means D, G, P, C, R, I, K. Okay, these two are the parts that are outside of X intersect Z and also outside of Y. So D, G, P, C, R, I, K. Again, order of the letters doesn't really matter. Third one, B3. B3 is Y intersect Z intersect bracket X intersect Y. Y intersect Z is here. Okay. And X intersect Y is here. So intersection of both means inside both areas will be just this E. So yeah, answer is basically the E. So answer is E. Just like that. All right, that is question 8 here. Then we have the question 9. Mr. Garnison is the manager of an insurance agency. So he recruits 2 active insurance agents to sell the latest insurance scheme valued at 100 ringgit per month. 10 ringgit. I wish it were 10 ringgit. So besides selling insurance, each agent needs to recommend at least 2 new insurance agents. So in the incomplete tree on the right, M represents the manager, A1 represents first level agents, A2 represents second level agents. Okay. So part A, if there are 30 agents in January, complete the given tree. Yeah. So 30 agents in January. So basically, what we do is we branch out until there's basically 30 agents. So basically, we start from the manager branch down. We have 2 agents. Branch down again, we will have another 4, means total of 6. If each of them branches out again, okay, it will add another 8. Yeah, 6 plus another 8, which is 14. Branch out again, another 16, which adds up to 30. Yeah, means in total, there will be 4 levels of the agents. So these are A1, A2, yeah, means these are 3rd level ones and these are 4th level ones. Yeah, basically that's how it works. So for part B, table here shows the percentage of basic commission received by an agent and the manager for every insurance policy sold. Okay, so calculate the total basic commission received by Mr. Ganesan in January. If the minimum number of insurance policies sold by an agent in January is 18. So they say there are 30 agents in January. and the minimum number of insurance policies sold by an agent, means one agent, okay, is 18. So it means yeah, assuming that each of them sells 18, so the total commission by Mr. Ganesan, which is the manager, he gets 2%, okay, of the 100 ringgit for each insurance, and the number of insurance will be the 30 agents times 18 insurance policies per agent. So I take 2/100 times 100 times 30 agents times 18 policies per agent. Then you will get the 1080. Yeah. So it's basically, this is from the percentage. 100 here is from the 100 per month. 30 is the number of agents. This is number of policies per agent. Yeah. Okay, that's the B1. Then B2, minimum number of policies that an agent needs to sell in order to receive basic commission of at least 1,000 ringgit. So this is only on the agent themselves. 1,000 ringgit, an agent will receive 25% commission. Means for B2, it's basically number of policies. So it's basically based on the rate. The rate is basically amount, the price of the policy over the number of policies. So to reach 1,000 policies means you have to take 1,000 policy divided by the commission that they get per policy. Okay, so let's count commission per policy. Means I just count 25% times 100 ringgit, which is 25 ringgit. Each policy they earn 25 ringgit. So number of policies will basically be 1,000 ringgit divided by the 25 ringgit. Yeah. How many 25 ringgit to get 1,000 ringgit, which is 40. That's why minimum of 40 policies. That's how it works. That's for the question 9 here. Then we look at the question 10. The diagram here shows the growth of a type of cell. It is given that on the first day, there are 4 cells. Second day, each cell produces 3 cells. And then on the following day, each cell produces another 3 cells. So each time it adds another 3 for each of the branch. So the process of producing new cells repeat at the same rate. So on which day will the total number of cells exceed 50 for the first time? Okay. So basically, each time it will add 3 times. Yeah, add 3 times of the branch that we have. So like the first is 4. Second is 4 times 3. See, there are 12 branches here. Third one will be the 12 times 3, which is 36. And the fifth one is the first. First day, second day, third day. So the fourth day, it will add another 36 times 3, means 108. Yeah. So actually, when it exceeds 50, if I look at the third day, 4 plus 12 plus 36. 4 plus 12 plus 36 is 52. So it already exceeds 50 for the first time. So actually, for part A, it's just the third day. Okay. This is the first. Second, how many extra in each day? Third, fourth. Yeah, means first day there is 4. Second day, 4 plus 12, 16. Third day is 4 plus 12 plus 36, 52. Yeah. And fourth day is 50. Basically 52 plus another 108. Then it's 160. Like that. Yeah. So fifth day, they want fifth day. So plus another 3 times. So 324. Okay, 108 times 3 plus 324. That's the fifth day. So it means I take the 160 plus this, plus 324. So it's 484. Yeah, 484. That's how I get. Part C, if the lifespan of a cell is 5 days, calculate the total number of cells on the 8th day. Okay. So lifespan of a cell is only 5 days. Yeah. So means on the 6th day, it will still branch out. Yeah, it will still reproduce new cells at that rate because it's only the new cells that will produce the next one. Okay, the older cells doesn't reproduce anymore. It only reproduce once anyway. So it doesn't matter how many dies, it will still add at the same rate. So we add until the 8th day. Okay, so after 324, 3 times will be 972. So I take the 484 plus 972, get 1456. Then the next day, the 972, I times another 3, 2916. Then 1456 plus 2916, 4372. And the next day, it adds another 2916 times 3. 2916 times 3, I get 8748. So on the 8th day, 4372 plus Actually, don't need. I can do that. 8748, and then I minus back the ones that died from the first 3 days, because they only survived 5 days. So only from the 4th to 8th will survive. So it means I minus back the 52. 13120 minus 52. Yeah. 13068. 13,068. That's how you can get. So if you don't want to do that, you can also, I don't need to add up all this, means I don't even need to actually count all this. I just need the ones on top. I just add from the 4th day to the 8th day. You can see, if I just add straight, 108 plus 324 plus 972 plus 2916 plus 8748. You can get 13,068. Yeah, either way, I will get the same answer. All right, so that's how it works. So yeah, basically that is all for the chapter 5 of Form 4. So these kind of questions, I highly doubt they would really ask. Maybe something like this, the sets is more possible. Or questions like this would definitely be way more likely to be asked from this chapter. Okay. I have no really much clue why the textbook writers want to write these kind of questions, but I don't think these are very good questions, to be frank. But anyhow, these are the questions in your textbook. So either way, you do need to be able to solve them properly, which is why I'm here to help you. So yeah, basically that's it for this video. I hope you all have managed to learn something from this video. So before you leave, just giving you a preview, I'm from Pusat Tuition Teliti. Our tuition center, we do offer, we have all kinds of books. We do sell some of the books online. Okay, we also offer tuition classes, both online and also in physical. So if you are interested, please do contact us. Yeah, if you like the video, if you think you have learned something, please do comment, like, share. Thank you.